So, good day. My name is Jerome Villarosa, and today I'm going to explain all about the sunrise and sunset calculations and its amplitude. So, we do have our given here, which is 1st of December 2017, and its observer's position it's north, latitude north 10 degrees, and then 19.0 minutes east, and for our longitude it's east 123 degrees 53.0 minutes, and its location it's in Cebu, Philippines. So our problem is we should calculate the sunrise and sunset, and also the calculation of the sun's true bearing at the time of sunrise and sunset using the amplitude table. So we do have our solution here. So our latitude it's n 10 degrees and 19.0. So how do we seek for 06 hours and 2 minutes? So we will convert it into time. So we do have our table here. So we'll observe the time on when it was rising. So this is the table for sunrise, and we do have our latitude, which is n or north 10 degrees, and we will just align it to up until the sunrise. So that is 06 hours and 2 minutes. So we do have here our time observation for latitude for sunrise, which is 06 hours and 2 minutes. So for our longitude, we do have here our east 123 degrees and 53.0 minutes. So how did we get our 0, 8, and 15? So we do have here our conversion of arc to time. So since it is 123, so we will locate it into degrees, and we did get 812. But we do have remaining, which is minutes of 53.0 minutes. So we will find minutes here. So it's 53, so it's 3 minutes and 32 seconds. So we will just add it. So that would be 0 to 2 hours and 13 minutes, and our zone difference is +8 since it is ahead of our location, which is in Cebu, Philippines, on 8 hours from GMT. And since we already determine its zone difference and why is it um +8, so we have to determine and add our local time of sunrise. So our local time of sunrise is 5 hours and 47 minutes. So we do have here our location. So our location, or I mean local time, is 500 hours and 47 minutes. So +8 again for zone difference, which is um, um, ahead of our location of 8 hours. So we have to find our GMT. So our GMT, we did add it, and then 21 hours and 47 minutes, and it is on 30th of November. So 30, no, day 30. So since it is on the 30th or day 30, so we will find it on the 30, November 30. So since it is 21 hours, so we need to find it in 21 hours and align it to S or south 21 degrees, and align it to the 21 hours. So it's 46.3. So that would be our declination. It's 21 degrees south and then 46.3 minutes, or south 21 degrees and 46.3 minutes. So our true bearing of sunrise is east 22.4 degrees south. So how did we get it? So we do have here our true amplitudes. So in our true amplitudes, we did get um 21. So we will just round it off 21. So we will just round it off to 22. So that is here 22. And then our latitude, which is 10. So we will get it 20, 22. So that would be 22.4. So to convert it into true bearing, we have to plus 90. So if we would calculate it, so 22 plus, 22.4 plus 90 degrees. So that would be 112.4 degrees. So that is our true bearing, 112.4 degrees. Now we have to calculate our sunset. So in calculating a sunset, it's just the same. We do have our latitude and longitude, and then we did get 17 hours and 37 minutes by getting its sunrise. So we do have our sunrise here, which is 17:37 minutes, 17 hours and 37 minutes. And then it just have the same longitude, so it just also have the same. So 08:15. So we did add it 123 and 8 hours and 12 minutes, and also for its seconds and minutes, so 3 minutes plus 32 seconds. So that would accumulate 0.22. So the difference is the latitude. So we did get plus 8, since we do have a location which is ahead of time, 8 hours from our GMT. And then our local time of sunset is 17.22, or 17 hours and 22. So we did get its local time, 17 hours and 22 minutes, plus 8 again, since it's ahead of time. And then we did get our GMT, which is 9 hours and 22 minutes on the 1st of December. So to get our declination, we have to find it on the 1st of December. So it's 1st of December here on Friday. So it's 9, which is 51.0, and S21, so south 21 degrees and 51.0 minutes. So we did get it already. Here, that it is. And then our true bearing of sunset is 22 degrees point 4 west. So how did we get it? We did get it through our latitude and 22 degrees. So that is 22.4, since it is rounded off. And then if we would calculate it to get the true bearing, then we will just 22.4 minus 360. Oh no, 22.4 plus 360. And 2.4 plus 270. That would be so you will just subtract it to 270. 270. Then you will get 247.6. So that is our true bearing of sunset. It's 247.6. So that is all for my explanation all about sunrise and sunset calculations and its amplitude.